Trees can greatly enhance a property's environmental, aesthetic, and economic values. When a future development site has existing trees that can be incorporated in the planning and design, they should be protected during development. Construction damage, however, is one of the most common causes of tree death and decline in urban areas. As cities and suburbs expand, wooded lands are converted into commercial and residential areas. Buildings are erected in the midst of trees to take advantage of the aesthetic value of the wooded lots. Unfortunately, if proper steps are not taken to ensure their survival, many trees will be lost later. Early involvement of a professional arborist is essential if trees are to be successfully preserved. An arborist can advise on which trees are suitable for retention, determine protection measures, and assist to design a layout that maintains tree health and safety during and after construction. 1. Describe how trees can be injured or killed as a direct and/or indirect result of construction damage. 2. Discuss the importance of an arborist's participation in the planning stages of the development if trees are to be successfully preserved. 3. Indicate the steps that can be taken to preserve trees on a construction site. 4. Discuss some techniques that can be used to preserve trees when the soil grade must be changed. 5. Explain the limitations of treatment for trees that have been damaged by construction. Construction practices can have a significant impact on the health of nearby trees. On the other hand, injured trees may survive for several years, gradually declining until eventually dying. This delay in noticeable symptoms often makes it difficult to associate current decline with the underlying problem caused during land development. Operating construction equipment such as backhoes, bulldozers, and cranes near trees often leads to damage. Branches can be broken or split, tree trunks severely wounded, and pruning cuts for clearance made by construction workers may form wounds that will never properly compartmentalize on a weakened tree. Often, the most serious damage to trees caused by construction is underground. The root system of a tree growing in a wooded area may spread a distance much greater than the width of the crown. Generally, the fine absorbing roots are concentrated in the upper few inches. 1 inch is equal to 2.5 centimeters of soil. These roots can be easily damaged or killed by construction equipment. When tree roots are removed or damaged due to construction activity, the trees may show decline symptoms within a few months, or the symptoms may not appear for a few years. Symptoms may include small or yellow leaves, premature fall color, extensive water sprout development on the trunk and main limbs, dieback, and eventually tree death. Construction equipment can injure the above-ground portion of a tree by breaking branches, tearing the bark, and wounding the trunk. These injuries may create permanent damage even if they are compartmentalized by the tree. If the injuries are extensive and the tree is stressed, it may never recover. Excavations and trenching needed to construct buildings and install underground utilities can sever the roots of trees in the area. If the grade is lowered near a tree, a large percentage of the root system may be removed. With an understanding of where roots grow, it is easier to predict and avoid the potential for damage. The roots of a mature tree can extend far beyond the drip line. In fact, roots typically will be found growing a distance of up to 3 times the spread of the branches. The amount of damage a tree suffers from root loss depends, in part, on how close to the tree the cut is made. Cutting one major root can cause the loss of 10 to 25% of the root system, depending on how many major roots the tree possesses. Root loss from excavations and trenching can increase the potential for uprooting and tree failure. Roots anchor a tree and provide mechanical support. Small diameter roots are critical to the uptake of water and minerals, but also function as guy wires. If support roots are cut close to one or more sides of a tree, the tree may fall or blow over. Unfortunately, it is not possible to determine exactly how much root removal can occur before a specific tree becomes unstable. An ideal soil for root growth and development has about 50% pore space. These pores, the spaces between soil particles and aggregates, are filled with water and air. Soils may be compacted intentionally, such as when soils are worked to create a stable building base, or unintentionally caused by vehicles and/or heavy machinery being used around the site. The loss of pore space caused by soil compaction can be devastating to trees. When soil is compacted, the pore space between soil particles is greatly reduced. This reduces oxygen availability to roots and causes an accumulation of carbon dioxide and other gases. Root growth may be diminished, and the ability to absorb water and minerals declines. Beneficial microorganisms and associations such as mycorrhizae can be harmed. Soil compaction reduces water infiltration and percolation and impairs drainage. The ability of roots to grow and expand into compacted soils is also reduced. Most people are surprised to learn that as much as 90% of the fine roots that absorb water and minerals can be found in the upper few inches of soil. Roots grow best where their requirements for space, air, and water are met, which is usually very near the soil surface. Placing soil over the root system or raising the grade may suffocate the roots, especially if the fill soil is fine-textured and compacted. Problems are generally worse if the soil is placed against the trunk. The effects of fill soil over trees' root systems may not be seen for many years because it takes time for the roots to succumb to disease organisms and poor drainage and aeration conditions. Even if the grade change is not in the immediate vicinity of the root zone, the water table or drainage pattern could be affected, which can adversely impact trees. Trees in a forest grow as a community, protecting each other from wind and other forces of nature. Removal of neighboring trees or opening the shared canopies of trees exposes the remaining trees to sunlight and wind. The higher levels of sunlight may cause sunburn on the trunks and branches of trees with thin bark. Also, most forest trees have long, thin trunks with little taper. If neighboring trees that helped provide protection for many years are removed, the remaining trees will be more prone to breaking from wind or ice loading. Knowing the effects of construction on trees requires an understanding of the biological needs and growth processes of trees, individually and in groups or forests. Every aspect of tree health, growth, structure, and development can be affected. The impacts of construction are cumulative and can place a tree into a spiral of decline that might not be recognized to the untrained eye until it is far too late. This fact highlights the need to involve a professional arborist early in the planning stages of construction. Development is the process of preparing the land and building structures to accommodate a variety of uses. If tree preservation is to be successful, trees must be considered in each phase of land development. Planning, assessing the potential land uses, selecting the most feasible and appropriate use, determining the general project layout. Design, creating plans and supporting documents to describe the project. Grading and construction, conforming the land and building the project. Maintenance, managing the project following construction. Construction typically follows a sequence of events. Site clearing and demolition to clear the site from all existing structures and vegetation that were not expressly identified to remain. Rough grading to create the project's grade contours. Installation of site-wide water, storm, sanitary sewer systems, and utilities. Grading for establishment of finish pad and road grades. Construction of roads and buildings and installation of utilities to structures. Fine grading and installation of landscapes. The most important aspects of construction for the arborist to understand are those that occur below ground. Requirements for these activities are largely determined by soil, civil, and structural engineers. The arborist should become familiar with common terminology and work procedures involved in these processes. Structures such as buildings, roads, patios, or utility trenches must be built in such a way that they are stable and safe. Therefore, specific engineering standards regarding soil compaction, footing and foundation design, and depth and separation of utilities must be attained. In many situations, the building standards and local codes allow limited flexibility for modification. Normally, the arborist must work within these requirements to ensure successful tree preservation. In almost all cases, the original soil is used as the building base